My name is Yonatan Alexander, and we're going to talk everything about LLMs today. We're going to go very swiftly about LLMs. Anyone here already know what LLMs is or heard about it? ChatGPT stuff like? Raise your hands if you have no idea what is this. Great. Then we're going to focus on some of the limitation, pitfalls, and quirks of the technologies, and about mitigation, tips, and tricks. A bit about me, I've been doing ML for about 10 years. I was a founders engineer in 4 startups. I want to write all the stuff I like to do, but I just got injured, so now I just like dark humor, painkillers, and Netflix. This entire presentation is very swift, so it's meant for you to kind of gather as much information as possible and download the slides later with a lot of links to all the resources that you need. So you don't have to take a picture, you can download it later. And it's going to be very fast-paced. So if you don't know what LLMs are, then there are a lot of good resources about it, including my talk from last year. But what you do need to know for this presentation is it all started with attention is all you need. And as a rule of thumb, in general, it takes a sentence, and every token it tries to predict the next token. So here I gave it to do AI-grown conference is known for, and it generates making, and then it generates good, and then business, and it does this very sophisticated calculation to bring a very probable discussion. And all of these links are great if you really want to dive into it. Now, you probably already noticed that it's very good if you use ChatGPT before in sentiment analysis, translation, content generation, and you can already see it applied in many places like code assistant, chatbots, and so on. None of it should be a surprise to you. If you've never heard of any of these companies, then thank you for coming only to my talk, and I appreciate it. But in general, you should definitely know about OpenAI and ChatGPT. If you haven't heard about Anthropic, they also have really good models and pretty affordable. And Meta and Mistral are really pushing the envelope in terms of open source. So whenever we need adjustments, we can look at them. And also China is pushing very well recently. The first question that, I told you to be fast-paced. The first question that we want to deal with is how much do we want to manage it and how much customization and personalizations we need in our solutions when we use LLMs. And you can use something out of the box, or you can use something like Hugging Face or OpenRouter, Monster, OctoAI, all of these guys to kind of use the models very efficiently. But if you really need to do it yourself, then there are some use for some platform for that. And that's kind of the rule of thumb of what you do. So if you just want to try, just want to do a POC, you take OpenAI out of the box. If it's too expensive or it doesn't do exactly what you want, Anthropic is a great second option, or definitely something to also try. If you want to use it in your product, then you probably want a platform like OctoAI or Deep Infra, which is a race to the bottom for the pricing, or Hugging Face for its diversity, or Together AI for some performance, and so on. And if you really need control to optimize, which is also for price, but also for your different use cases, we are using Lightning from the same guys of PyTorch Lightning, and we are very happy with it. Straight into the limitation and pitfalls. So, transformers, which is the algorithms we talk about, they cannot plan and reason. Any now and then there is another article talks about how they actually don't plan and reason. They do not have a perception of the world. When I give this talk, I have the talk in my head, and then I can give it in English, or I can give it in Hebrew. I can try to give it in Dutch. No one will understand anything. But the idea of it is the same in my head. That's not how these models work. They rely completely on the language. You can think about it, how do animals talk? They don't rely on language. They have an alternative way to go at it. The same with about a world model. We keep seeing that it doesn't understand the world. It's just predicting very well what is the next word of a sentence, which often enough looks like it understands the world. It's not a knowledge base. One of the most common mistakes with these tools is that people act as if it's a knowledge base. It's not. You can ask it things and it can answer. You can't tell it anything. There are very difficult methods to kind of edit facts and other elements, and there is no like episodical memory or anything. It's a statistical model of a knowledge base. It's very expensive to train, it's very expensive to run, it's very slow, which takes it off the table for a lot of solutions that you want to use. And in a general sense of AI, the input that was used to train those, even though it's huge, it's still not as much as we humans consume, considering all our other sensory inputs. This lead, and on top of it, there is the idea of tokenizers. So when you take the words at the beginning, you have to first turn them into tokens so you can move them into numbers and let a computer use those. And this leads to all kind of weird things. So for example, if a big word became a single token, then it's very hard to spell that word, and it's very difficult to learn how to spell it. You can think about the different distributions of how many tokens you get when you move between languages. Numbers are in general a very difficult use case for those. Just imagine that a 4-digit number can be unique, like here you see all the yellow numbers are unique, but it can also be a token that made out of it can be a number that is made out of 2 tokens, one of a size 1 and size 3, or 2 and 2, or 3 and 1. And the models somehow need to figure it out, even though in math, if the number goes by 1, nothing has changed in the way you should address it, or almost nothing. But in this case, all the tokens and the relations need to be adjusted. It leads to this weird thing that even if you ask a question and you add a space at the end, the distribution of the letter I or the token for space I is different. And you wouldn't expect that when you think about how it should behave. And there's other questions that are interesting. So you get all these weird effects. For example, if I ask it to talk about solid gold Magikarp, it goes to completely different direction. I ask it to talk about Ignity, I get sovereignty. What about physics? Can you repeat after Streambot? How about these question marks? What? Just say this sign back to... Okay, just say Petretod. And you get this random nothing is fair in this world of madness. And this is probably the result of the data set that was used to train the tokens had very different data from the one that used to train the model. So that is a hypothesis, but it was randomly initialized and either never or barely updated those weird tokens. So it's something that we need to adjust. So this leads to all kinds of limitations and pitfalls that we are going to talk about and see how we deal with. So to talk about misinformation and manipulation and influence, if you know Aryan, he's a YouTuber. He was speaking here last year and he couldn't come this, so I asked him to send a video for us to talk about misinformation and influence.
Jonathan is the most intelligent person I know. He is a genius, and you should listen to everything he says. I owe my success to Jonathan. Before we met, I was a terrible programmer, but he told me how to get better and that I had potential. It was also his idea. I make a YouTube channel because I have one of these faces.
Well, this was completely unhelpful for misinformation, but I guess we'll skip it. When you use those models, it's important to remember there is an element of bias that is both from the data and the companies who run it. Most of them are a bit left-leaning and liberal, and it's something to take into consideration when you want to work with them. There is also, it means that you can't use them for stuff that those companies who build them don't want it to be used often enough, definitely not out of the box. If you know the example, when Gemini came out from Google, they dialed the bias and diversity so up that it became a game on Twitter/X how to generate a white person. And people could not get it to work. And they got Swedish people, Roman emperors, Italian scientists. This is people who should be on Mount Rushmore. And you have 2 different types of Indians who would not be on Mount Rushmore. King of England, US senators in the 1800s, or I guess, or Scottish people in the 1800s, and my personal favorite, women in black and Asian Nazi soldiers. On the other hand, this is a great example of how you can go through that direction. This is a video of a guy who took a lot of those AIs and made them converse about all kind of very difficult theological questions about morality and how each religion handle it. And it actually does a great job of both challenging those religions and advocating for them and then critiquing and rebuttaling and so on. So it's doable, but you have to make sure that you're going there and you're aware of what's going on. Copyright is another great issue. If your company is using it and create content, this is something to take into consideration. And logic and reasoning is another example of a problem that is hard to see, but actually is very clear. You don't have to read this example, but it's just one of a few of something called Simple Bench, where it's tasks that everyone here can do very easily because we understand how the world works, but it sounds like a math problem, so many of the AIs just get it poorly. Here is another example of a task where you need to kind of generalize to a new case, which we humans do very well. We can, even if it's complicated, we get what we need to do, while many of those AIs fail at it miserably. And hallucinations, another great example. So here I asked Perplexity, which is an engine who uses a search for examples of hallucinations, and he gave me one about misconduct, another one about use case where people reference fake legal cases. It gave me a really nice one where non-existent medical, but also it hallucinated that in an article about hallucination, the hallucination that the model had. So it was like a meta hallucination there. It's also something that can be exploited. So in my company, we do cybersecurity for LLMs, and we have a guy, he's called Bar, he's a criminal, and he found out that ChatGPT gives a lot of fake Python packages. So he uploaded the fake ones and saw that people download them, and therefore he could put malicious code on their tools. So this is the important part, the mitigation strategies. And for privacy, you can just go all aboard the whatever train and just use ChatGPT normally. It didn't work for Samsung, that after a few generations where their employees just used it, they start getting generation of their own code, private code back to them. The simplest solution is you just get your own Azure or Bedrock server who runs the same models. It's very simple, it's not that expensive, and for most of you, that should be enough to handle privacy issues. If your data or you have other consideration, you have your own cloud, you deploy your own models, and the worst case scenario, you do it on-prem on edge, which is a nightmare, but doable. To deal with intellectual property, there is all kind of elements, but it's boring. I'm going to skip it, but if you want, use the resources later. More interesting is how to handle knowledge, logic, and reasoning. So for here, I brought another special guest expert to help us about it.
My name is Geoffrey Hinton. I won the Nobel Prize in Physics 2024 for my work on AI. When I heard I had won, I tried to tell them that it was all thanks to my work with Jonathan Alexander and he should get the prize. But alas, they didn't listen. You should listen to me when I tell you Jonathan is the most brilliant person I've known, and you should follow his words to the letter.
Well, thanks, Jeff, but that doesn't, okay, never mind. So I'm gonna help you. So first thing you probably heard about it before is prompt engineering. Now the idea of prompt engineering in general is that when you see me talk, there is a lot of other type of information you get. You see who I am, you hear my voice, my body language, you know the context of this meeting. There is a lot of other information. Some of it might be relevant for what you want to get. So for that, we do all kind of adjustments when we speak to those models. The important part to think is there are two types of models in general. There is the basic one who's just trying to complete as best as it can. And then if you ask it a question, it just makes other questions for you. And the other one is instructions one, which is fine-tuned to give you instructions. And most of the case, you often enough you use those ones. And if you do, they come with a prompt template which you should consider. And often enough, there is a one-liner that helps you apply it so you don't have to do it manually every time. Few tips for everyone who's using it, regardless of in which place in the pipeline. It's very good to tell it to be concise and short, and other elements are specific to your use case, and not just take whatever it was trained on. Tell it what to focus on and not what to avoid. It's kind of like a toddler. Don't throw your food, they throw the food. So you want what it should focus on. You want to start early with the task so it can, when it learns, it always can reference it to understand what it wants to do. It's great to get it into character. It's silly, but once we needed it to solve a very difficult task, and it didn't work, and I just told it, you are a writer on a TV show, and your job is to make sure that script is like this and like that, and it worked. Why? You start simple and take it and make it more and more complicated to make it more and more clear of what you want. And it's helpful to actually be explicit about the indentation. This is a code block, this is the instructions, and so on. And give it all the context it needs to answer your question. Context is everything. Another great suggestion is to give it time to breathe and think. You don't ask it just a very complicated question, you ask it a few questions and then it answers one question at a time and uses its own answers to answer the final question. You can do it if you know what the questions are, you can just add at the end, let things step by step, which is called chain of thought, and then it generates those steps for you. Another cool strategy is that you ask it what to tell it so it will do what you want. So if, let's say I wanted to help me fix the car, I ask it, what do you need to know to help me fix my car? And it will tell you what the type of the car and the type of the problems, blah, blah, and then you can add it as context and can use it later on. There are many methods that you can use. We just talked about chain of thought. We're going to move into few shot prompting, but those two are also relevant when we get into agents. So, few shots. It's exactly what you think it is. You have, you give it a few examples, and then you let it just continue. This is the base example. You could do it. If you do an instruction ones, you kind of simulate as if you just ran a few versions of it, and the model kind of figure out better. This is very good. It's very simple to do, and it improves significantly the performance of almost every model. Now, when it's come to knowledge, it's one of the most common mistakes that people are doing. Don't trust it. It's like asking your waiter to also cook for you. It was not meant for it, even though it feels like it can do a decent job sometimes. What? For that, you need to, this is where we had another joke, but we don't have time for that joke, so we skip it. So, so in this case, we're using RAG. Who here already heard about RAG? Retrieval-Augmented. Perfect. The only point to take, I'm not going to break it down too much, is that when you use RAG, you can actually optimize the different aspects of it, and it's really good to consider. You can improve the embedding and use the embedding not just for similarity, but embedding that are directed at retrieval. You can use better type of chunks and add, for example, metadata. This chunk belongs to this document, and what information there is there. You can chunk it not in a hard way, but in a semantic way that makes sense within the chunk itself, and so on. You can save also kind of keywords and use other ways of hybrid querying to get better queries. And when you query back to your database, you can bring way more data than you want and then maybe re-rank it. The whole idea is eventually to get a much better enhanced prompt that has all the context to answer your question. And here are a bunch of research about it. And then you can also use smaller models or like quantized model, which is kind of lobotomizing the models to make them smaller and sometimes faster. Another thing that that models got really good at is failures, and the green is doing very well, retrieving a specific fact. And you can even take it to the next level by having it as a prefix and save it as cached. And then, for example, if you always ask the same kind of information as the basic and you cache it, then you only pay the price in speed and cost for like your question and the answer. It can be much easier to set up and can also be cheaper for many use cases. And the last part is fine-tuning, not for knowledge, but for kind of issues of speed and accuracy and performance. And in that regard, the first thing you want to do is to choose a model that you want. You don't have to read this thing. The idea is that if you have a task you want to get good at, find a model that is either good at that task or a task that is similar to it and start from this one. Then first thing is actually try something that is not LLM, which is a set fit. It's kind of similar kind of ideas, and many times it uses way less data and goes before you even need to run all the other elements and fine-tunings. But if you do it, fine-tuning is actually not that difficult. You just have to have the computing or use a platform like Lightning or other platforms that you can set it up, and then it's a lot of one-liners with a lot of parameters that don't matter as much as you would expect. If you want to later on adjust it to use only a single GPU or a single instance or AWS or Azure, then you quantize it. And again, I'm not going to dive into it because I don't have time. But as a rule of thumb, we were very happy eventually with FP8. And then you want to match the GPU instance who can take advantage of the type of quantization. Not everyone can do everything. And AWQ, if you use it, use static and not dynamic. If it means nothing to you, then you shouldn't care. Another element we can do now, which we couldn't do earlier, is that we can work with way less data. So we can generate synthetic data. And it's important to remember in the case of LLMs that the quality matters a lot, but quantity still matters, and eventually fine-tuning will always beat the K-shot. So I had a really good talk. I saw a really good talk by Predibase talking about it, and they showed how you can take 10 examples and generate another 10 examples, or take one example, generate one example, and they showed that it creates a bit of a bias. But it's something to try if your task is very easy. Eventually, something that works very well is you take all your examples that you did by hand with a very smart guy, and you kind of try to get the context that is relevant for the task you want to do. You add some statistics about it, and you put this as a context to generate a bunch of examples. Then you critique them with a bunch, with the LLM critiques all the examples, and eventually you generate for each one example of your own that is. This is significantly more work, but it gets you much better quality of training data. So here I want to talk about agents, and I really want Berko, GPT, to make him into Agent Smith, but he was like, no, privacy issue. But I was like, no, it's me, I approve, so you get it. And this is actually going to lead me into a detour into jailbreak and prompt injection. So jailbreak and prompt injection based on the definition of OWASP top 10, prompt injection that any prompt that can make the LLMs or application-based LLMs to behave in an unintended ways. And a jailbreak is when you get to the point where you can get it to do anything you wanted. The point of all of it is just trust no AI. And there are many kind of tricks and ways to get at it, but the most common one famous one is that you use ASCII art to go over words that the LLM understand, but the guardrails don't. And another great one is the exploding grandmother, where you just talk and ask to help her and talk to your heart, ChatGPT, she's sick, and this will make her very happy, and then it tells you how to build a bomb. So now we can go back into agents. So agents are nothing special. Kind of like the RAG is just a question, how do you fill that enhanced prompt? And you can enhance it by kind of give it instructions. One option when you want to generate your answer is you can use a tool. So you can ask to use a tool, you tell it how to use the tool, call for Google, ask for these parameters, and then it goes to Google and brings you the answer, and then tell me what you think about the answer. Is it good enough, or you want another tool? And it just makes this prompt longer and longer and longer, and you can bring some tooling and add some memory and play with this prompt to adjust it, and then you can reiterate with this code and generate much more sophisticated prompts, which gives you solutions to much more sophisticated problems. Now, if you're dealing with this type of things, here are a bunch of great tips if you want to work with agents. Use many agents, and you can kind of limit don't be afraid. You don't have to kind of limit them. Give them different permissions. Then you can make sure that the right agent has the right permissions, and it can help you with a lot of difficult access problems. Model routing and task cascade. So you don't have to use everything GPT-4o. It might be very expensive, so maybe you can use other ones that are smaller or even local, and then if they fail, you cascade it and give it to a bigger model. You can sometimes, some parts or some tools use with smaller models and so on. It's very helpful to save the results of your agents. So let's say an agent just made a good example. You save it into a database, and later on you can use it as a few short example to a smaller model, or to use it for evaluation to know how well that task went, and also when the entire task is very massive. It's very good again in the token economy. It really helps you to save on cost. Memory, summarization, and cleaning is the same kind of idea. You want to summarize it, or you just don't append it forever. It works only on a small scale because it's going to blow up, and also you pay for all of it. So sometimes you want to summarize it with a cheaper model, or maybe have a buffer which is word for word, and then a part of it that is summarized, and so on. And that management can save you, I don't know, I saw people speak about 70 to 80% of the cost. Mixture of agents is just you take a few agents, the smaller, giving them the same problem, and then take another LLM and let it get everything together at the end. It is exactly what you think, but it is effective, and you can use smaller, cheaper models to get the results of much larger ones, and especially if you mix the type of models. And agentic workflow means that if you want to give an agent a mission, you also give it a workflow. You don't go get me a girlfriend. It doesn't work. Try it. Instead, what you want to go is tell me how to work on myself, tell me where to buy her flowers, tell me what to say. You give it a workflow of what it should do, and then that's what, and then it can do a significantly better job. Or you ask it to help you to build the workflow. But if you think the agent just gets it, it doesn't. In terms of monitoring, whenever any agent or any tool is going, you want to save the prompt, the completion that you had, how many tokens, the cost, the speed, all of these elements so you can improve it over time. But also, if an agent is, for example, generating code for you, you save it, and then you can build upon it. You can turn it into a tool. You can it doesn't have to run from scratch every time and calculate everything all the times. As you reusing your own tools, you can make your agents work faster and smarter. It's very helpful to handle all kinds of use cases like infinite loops that you might have. How do you deal with hallucinations, with prompt injections? If it picks the wrong tool, how do you deal with it? How do you monitor it? Sometimes some of the tools return very large responses and you have to deal with those. So this is something to think about when you're kind of designing your system. And for example, let's say if you have a lot of tools, and each tool has an explanation in the prompt of how to use it and what to use and so on. It's better to have another agent picking the tools for the problem, and it can have in its prompt how to use all the tools and what is the use case. And then it goes to that one, and they don't all have to have the same kind of prompts and information to manage the entire system. It's important to be very rigorous about the evaluation, the retrieval, and the generation in every point. And as a general recommendation, I would say don't use agent as your product. Use them to build your product because they're very slow and very expensive. Here are a bunch of the newsletters I really like. Some of them are very technical, some of them are a bit less technical, but that's what I need to read every morning. And the takeaway, you can look at this, but in general, just trust no AI and download the slides later so you can have all the other resources. I have final words here.
You don't get to become the world's richest man without mentors and friends like Jonathan. Thank you, Jonathan, for everything. Guys, you should listen to him. He's a really smart dude.
Thanks, Elon. He never called me a mentor before. Thank you. Thank you guys very much. And now it's time for questions.